Hello, good morning everyone. We have already seen the video part 1 of this chapter electricity class 10. Now today we will start the next part. In the next part we will start from Ohm's law. So in 1827 George Simon Ohm, he gave us the relation between electric current and potential difference, and that law is known as Ohm's law in honor of him, because his name was George Simon Ohm. So this law we call it as Ohm's law. So what is Ohm's law? What is said in the Ohm's law? According to this Ohm's law, at constant temperature, or in somewhere you will find some places, some books written, when the physical conditions are kept constant. So in that physical condition comes our temperature and pressure. That means when the temperature and the pressure is kept constant, but here pressure is not required, there is no dependence of pressure. So what we say, if we omit pressure and we say directly in this way, directly, that at constant temperature the electric current flowing through a conductor is directly proportional to the potential difference across the ends of the conductor. This is known as Ohm's law. Or you can say, according to Ohm's law, at constant temperature the electric current flowing through a conductor is directly proportional to the potential difference across the ends of the conductor. In video number 1 I have already explained you all what is potential, what is potential difference, what is electric current. So here we are seeing that electric current, according to Ohm's law, electric current is directly proportional to the potential difference across the ends of the conductor. If I denote electric current with I and potential difference with V, then I is directly proportional to V. Now I can also write it in the same way, that V is directly proportional to I. When we will remove this proportionality sign and we will write in this way, V is equal to Ri, where this R is the proportionality constant, and this proportionality constant it is known as resistance. So here if I write in this way, that V by I is equal to R, that means we can write V by I is equal to constant. This R is the proportionality constant. So we see here that V by I is constant. Now I can say this way also, that I is equal to V by R. That means the current flowing through a conductor is directly proportional to the potential difference across the ends of the conductor and is inversely proportional to the resistance of the conductor. So how do we define resistance? The property by which an electrical, we can say the property by which a conductor or any substance opposes the flow of electric current, that is called resistance. So if we have a conductor, then what will happen? In the conductors, or those that are good conductors of electricity, the electrical resistance is less. Electrical resistance is very less. Those that are insulators, the electrical resistance is maximum, we can say, or it has got high electrical resistance. And in the conductors and insulators, we can write the definition, this one only. In the lower classes you have just studied about the conductors and insulators definition also, that conductors are those that allow electric current to pass through them. So you can write their definition also, or you can write this definition also, that conductors are those substances which have got low electrical resistance, and insulators are those substances which have got high electrical resistance. That means resistance is the property by which a substance opposes the flow of electric current. That means it is not allowing electric current to pass through them. Now this resistance we got here as the constant, and the SI unit of this resistance is ohm, and symbol we write in this way. Ohm, it is in honor of the same scientist George Simon Ohm. Now we will see the next part. What are the next part? We have got numericals. So you may be given here three things we saw here. In this part we saw three physical quantities. Out of these three, two may be given to you, and the third one will be asked to find out. So you will solve numericals on that. Now we have graph between potential difference and electric current. So when graph is drawn between potential difference and electric current, then the graph will come to be a straight line passing through the origin. And many experiments were done by Sir John Simon Ohm to prove this relation that V by I is always a constant for a given conductor at a given temperature, at a constant temperature. And when he drew the graph, then the graph was a straight line. So here it is given experiment to verify Ohm's law that you can study from your book also. Usually experiments we are not asked in exam. Next we have the definition of good conductors, resistors and insulators. So good conductors and insulators I already told you. Now we will see about the resistors. So what we have in the resistors, we can say they have got very high electrical resistance, and insulators we can say that insulators are those substances that have infinitely very high electrical resistance, infinitely high electrical resistance. And in the good conductors we saw that those that have got very low electrical resistance. Now next part, factors affecting the resistance of a conductor. What are the factors on which the resistance of a conductor depends? Before going to that, let me tell you here that R is equal to, we have studied V is equal to Ri or IR. That means I is equal to V by R. This relation we have seen. So in this what we are seeing, R is directly proportional to V. That means if I will double the potential difference, then the current flowing through the conductor will get doubled. If I will halve the potential difference, the current flowing through the conductor will also get halved. Now, current flowing through a conductor is inversely proportional to the resistance. So if I will double the resistance, the current will get halved. If I will halve the resistance, the current flowing through the conductor will be doubled. Now we will see the factors on which the resistance of a conductor depend. The factors we will see on which the resistance of a conductor depends. So there are mainly four factors we will see here. First we have the length of the wire. Suppose we denote it by L. Then we have area of cross section of the wire. We denote it by A. And then we have got the next one is the nature of the material. What type of material it is. And the fourth one we can see length of the wire, area of cross section of wire or of the wire, nature of the material of the wire, and then the temperature. So these are the four factors on which the resistance of a conductor depends. The first one will denote length of the wire by L, then resistance is directly proportional to L. Resistance of a wire of a conductor will be directly proportional to the length of the conductor. If more will be the length, then the resistance will be more. If we will decrease the length, the resistance will decrease. Next one is area of cross section. So R is inversely proportional to the area of cross section of the wire of the conductor, whatever it is. That means if more will be the area, the resistance will be less. If area will be less, resistance will be more. If area is more, resistance is less. If area is less, resistance is more. Then third one, we have got the nature of the material. Since different materials are different nature, some allow electric current to pass through them, some do not allow electric current to pass through them. So what we will see here, that depends, resistance also depends on the nature of the material, whether the conductor will allow the electric current or it will not allow. The resistance will be dependent on that nature, that material, what type it is, whether it is of a allowing nature or it is not of allowing nature. So if it is of allowing nature, that means if it is such type that it is allowing electric current to pass through them, so resistance will be less. If it is of such a nature that it doesn't allow electric current to pass through them, that means resistance will be high. Next we have temperature. As I told you, at different temperature, in the law only I told you at constant temperature, because when the temperature decreases or when the temperature increases, the resistance also changes. So what we will see here, the resistance of all pure metals increases on increasing the temperature. The resistance of all pure matter or pure metals, we can say, increases on increasing the temperature and decreases on decreasing the temperature. So now we saw here these two things, that R is directly proportional to L and R is inversely proportional to area of cross section. If I combine these two, so I will get R is directly proportional to L by A. And when I remove this proportionality sign, then what will happen? I will get rho L by A. This one is known as resistivity. This rho is known as resistivity. R is equal to rho L by A. That means R is both these things I have combined. Combining this first one and second. What we got? R is directly proportional to L here, R is inversely proportional to L. When we combine both of these, we get R is directly proportional to L by L. When this proportionality sign is removed, then a proportionality constant comes here. We call them as rho, and it is known as a resistivity. It is known as a resistivity. This resistivity of the material is also known as specific resistance. So if I write this resistivity as RA by L, we can keep the formula, this one, resistivity as RA by L. From here I have taken. That means this is the formula for finding the resistivity of a substance. The resistivity of a material, of a conductor, can be found by using this formula. Resistivity is equal to RA by L. But resistivity of a material does not depend, or the specific resistance of a material does not depend on the area of the cross section of the wire or the length of the wire. It depends on the nature of the material. So we can say that resistivity and resistance are numerically equal. Resistivity and resistance are numerically equal. If I will increase the resistance of a substance and make it 2 times, then resistivity will also become 2 times. If I will decrease the resistance and make it less, the resistivity will also decrease. Now we have got the SI unit of resistance. We already saw it as ohm. Let us find the SI unit of resistivity. So here we have got resistivity side, SI unit. Here resistance we have got ohm, and of area it is meter square, and of length it is meter. This you cancel, so it will be ohm meter. So the SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Now sometimes we are given certain material, for example a copper wire. Copper, it is given that the resistivity of copper is 1.69 into 10 to the power minus 8. 1.69 into 10 to the power minus 8 ohm meter. What does this mean? What does it mean? It means that if I will take a copper wire, by saying this we will mean that if we will take a copper wire or a copper rod of 1 meter long and 1 meter square area of cross section, then the resistance will be 1.69 into 10 to the power minus 8 ohm. So the resistivity of a substance 1.69 into 10 to the power minus 8 ohm meter is given of copper wire. So if we are asked, maybe some other material we are given, iron we are given, copper, zinc we are given, aluminium we are given, and we are asked what do you mean by this? So we will say that if we are given this one of copper, then we will say that if we take a copper rod of length 1 meter and of cross section area 1 meter square, then its resistance will be 1.69 into 10 to the power minus 8 meter. The resistance of alloys are much more higher than those of the pure metals. You can see here different tables are given here. In your book also you can refer conductors, semiconductor, insulators. We have been given the resistivity at different temperatures. Now we have that of electric iron. You must have seen electric iron. When we switch on the switch of the electric iron, what happens? We can feel the warmth in the plate of the electric iron, the bottom one. And then what is happening? We are using them to iron our clothes. How it is? On what basis it is working? What is the principle of that working of that electric iron? The heating element is there at the bottom part of the that electric iron. The heating material is there, heating element is there, and that heating element is made up of alloy. It is not a pure metal, because I told you pure metal they have got less resistance, electrical resistance. This alloy they have got higher electrical resistance, so they are made up of alloy. And when that alloy is there and when we are switching on the electric current, what will happen? That alloy gets heated up because it has got high electrical resistance. It will stop the electric current, it will allow slowly the electric current to pass through that, and when the electric current will go slowly, in the meantime it will heat that part, that alloy, which is a metal plate of that which is placed there, made up of alloy. And because of that heating, the lower part of the electric iron gets heated up, and then when we put it on our cloth, because of the heat it gets ironed or pressed. Now we have numericals based on this formula. Based on this formula we have got numericals. Here 4 physical quantities are there. Out of these 4, 3 will be given to you, 4th one will be asked. 3 given and the 4th will be asked to find out. So we will solve numericals based on this formula also. So let me solve one question on this formula also, and this one also, or the same it is. So I am writing the question first on the board. So I have written one question. A simple electric circuit has a 24-volt battery and a resistor of 60 ohms what will be the current in the circuit. So we will see the solution. We have studied V is equal to IR or I is equal to V by R. So we have to see whether V and R is given to us or not. V is given to us, potential difference given. Battery is having volt of, battery is the 24 volt. So it is, potential difference will be 24 volt, 24. And then here what we have got, resistance. Resistance how many? 60. See here, this is volt, this is ohm. So all SI units are given. Now we will divide. 6 tens are 6 fours are. So what we have, 4 by 10. That means 0.4. Since these two are in SI unit, so that we will write the SI unit of current ampere. So this is our answer. Next we have this part. Another question I have done. So I told you I will give you question based on this formula. So I gave you one question based on this formula. V is equal to IR. Now we will see the another formula, that R is equal to rho L by A. We have already seen the formula. Now one question I have written based on that formula. A copper wire has a diameter of 0.5 millimeter and a resistivity of 1.6 into 10 to the power minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohm? So you are given the diameter. Diameter you are given. So diameter is given to us 0.5 millimeter. So radius will be 0.5 by 2 millimeter is equal to 0.25 millimeter. Now I convert it into meter, so it will be 0.25 into 10 to the power minus 3, because we divide by 1000, so it will go up, it will become minus 3 and it will be meter. So I got the resistance as, sorry, not resistance, radius as 0.25, it will be minus 3 meter. And resistivity is given to us as 1.6 into 10 to the power minus 8 ohm meter. We are given resistance as 10 ohm. So I had already told you that R is equal to rho L by A. That means rho is equal to resistivity. We have to find what will be, no, we have to find the length of the wire. So first you write R is equal to rho L by A, and now from here you can write L is equal to R into A by rho. So L we have to find. So this one, resistance how many? 10. Acha, area of cross section, this we must find. So what we will do, first we will find the area. First we will find the area of the cross section. So let me rub this part, and first we will find the area of the cross section. So area of cross section is pi r square, because wire, you know the shape, it is circular shape. So what we have, area of cross section will be circular, so pi r square, so 22 by 7, and into R will be 0.25 into 10 to the power minus 3 meter whole square. So it will be equal to 22 by 7 into 25 to 25 is 625 to 0.0625 into 10 to the power 6 minus 6 meter square. And now when you multiply this one and divide, so you will get 0.19. Let me do rough work how much, because this one is here. So when we will do 22 into 625, and then here we have divided by 7, so it is coming out to be this multiplied by this 1964 and to 10 to the power minus 6 meter square. Now we have length. Now we will write that formula. L is equal to RA by rho. Is it visible bottom? Yes, visible. So I am writing this part. R, 10. Area of cross section we have got 0.1964 into 10 to the power minus 6 and divided by this one 1 point. Wait, let me move the camera a little downward. See. So here it is 1.6 into 10 to the power minus 8. And when you will multiply and divide and solve, you will get your answer as 122.7 meter. So this is how we are solving. Next part we will see in another video.